double check to make sure that it is recording. Yep, so it's great. My daughter was borrowing my microphone for her music instrument practice. There's a program called, gosh, what's the name of that thing? Smart Music, that's it, Smart Music. It's a program, and if you play a violin or if you play flute or a recorder, it doesn't matter really what instrument you play, it can check your playing, so it can display the score, it can check your tempo, it can check whether you play correctly or not. If not, it will highlight which section you have you're not matching the piece and so on and so forth. And that's why you need a microphone to make it work. This microphone works really well, with that type of application. We had to turn down the sensitivity all the way so that you would play her flute right next to the microphone. But that also helps to eliminate all the background noise, because the background noise become insignificant compared to the flute. So it's kind of interesting. I wish I had that when I was a kid. When I had to practice piano and whatnot. Yep.
Are you teaching Android programming next semester?
I think that was scheduled, so we'll see whether the class actually gets to go or not. Right now, the contention point is the number of FTEs that we are allocated, and we have a lot of people. We have 5 sections of P300 this semester. So that will be putting a lot of pressure on cisp300, which we usually only offer 2 sections per semester. So that's why that might take up some of the FTEs that otherwise would be available for 362, which is the mobile app class. So we'll see. I'm not 100% sure yet. How they're going to allocate the FTEs.
What's your pre-rate for 360? Is it this one?
For 360, it is this class. For 362, it is just a co-requisite of this class. So if you have taken this class already, you're definitely okay with 362, which is the app programming class. Okay. So as usual, I'm gonna wait until the rest of the class is here. So I'm gonna go through a few articles that I just wrote this morning. Okay, so you now know what I do right before class when no one is coming to my office. One of the interesting things is somebody wrote an article that talks about Linux for your desktop computer. In other words, well, this is nothing new. Okay, I've been using that for many years. But the distributions that I use is not exactly user-friendly. In other words, it's really kind of archaic by today's standard. It does everything that I need to do, but for most people it may not seem as kind of user-friendly. One of the contender is Android desktop, okay, which is really interesting because Android started off with a mobile platform on cell phones and smaller devices, and now it's moving up to desktop devices or larger devices. It's not really surprising because I have a 1080p tablet. With a 1080p tablet, you actually have a lot of pixels on the screen, and as a result, Android has to support that too. And it's just one more step to get a mouse pointer available on the screen. So that instead of actually touching the screen, now you can use a mouse or a touchpad to control the interface. So that's kind of interesting. This part is, does anyone play games from Valve?
Yes.
Okay, so you guys heard about this already?
I don't know. What is
Your DNS cache is owned by Valve. Okay, so basically their software would scan your DNS cache on your own computer and kind of check what website you have been going to lately.
Really?
Yes, you can read the detail of that one.
Backdoor.
The objective is not to really invade your privacy, according to Valve. According to the company, the objective is to see whether people have been going to cheat sites and utilize cheats, because cheats also they go to specific websites. So a DNS cache would have certain entries of those particular domain names and also the IP addresses. Yep.
But you can't really go from visiting cheat site to visiting. You can't make that.
No, but they have specific URLs that they're looking for. So it's not just websites where people talk about cheats. These are sites that are actually where the cheat engine resides. So no one, just for browsing purposes or curiosity would be going to those websites. It's actually done by the cheat engine itself to go to a particular quote-unquote mothership to check for updates and whatnot. So it's kind of interesting because the cheat developers also know how to kind of evade this problem. They can manipulate the DNS cache to evade detection. So it's basically become a game in a game, in the gaming industry, because now you have the gaming company trying to go after the cheat companies, but this has been going on forever. I mean, this is it just keeps going and going.
I mean, you can just set up a proxy server and just use that, right?
If you set up a proxy server, you still have a DNS lookup though.
On a separate computer.
On a separate computer. But I think some of those cheats may not work with a proxy server. It depends on how it's all kind of set up. So that's kind of interesting. And not really totally unrelated, DARPA, which is the agency that belongs to the DoD that does all the training and research, they're now starting to train cadets and midshipmen to basically do cyber warfare. The objective is by year 2017, they want to train 4,000 security experts. 4,000 is a pretty small number. If you think about it, it's a really, really small number. Because what they have to do is to counter the cyber attacks from not just commercial hackers, but also from state-sponsored hackers from not just one country, but from just, if you can name that country, they can do it, right? If that country can buy a computer, they can have a hacker. So 4,000 people is not really a lot. I mean, if you scroll to the end here, I think
that's a lot of workload for them.
Oh yeah, I mean, if you only have 4,000 people, and this is also by year 2017, 3 years, okay? 3 years to bring the number of security experts up to 4,000. I think that's catching up, but it's not going to be there yet.
Are they looking for people already with degrees, or are they just training them from scratch?
I think that's from scratch. They're starting with cadets and midshipmen. So basically, anyone who's interested, they have this program for those people to join. But I think they have really kind of famous, trainers too. So they have, people who have been going to DEF CON for years, and win competitions as trainers. And some people may have the aptitude to get it done really fast too, to go through the program really, really fast. But I think in general, the demand of qualified computer security experts is going to outgrow the supply in the U.S. for really some time to come. I mean, it really is like that already. We are still playing catch up, and I think it will stay that way for quite a bit of time. And interestingly, people who are really good at this sort of thing, a lot of times they are taken by some other industries. Can someone name those other industries that will go to a engineering college at a university and say, okay, why don't you guys work for us? We make a lot more money. Financial, exactly. Wall Street. Wall Street actually hires a lot of people who would be engineers from universities. So that's it's interesting, the dynamics between various industries.
Programming engineers?
No, they just hire people who are smart enough to do programming, because those people would also be useful in the financial companies. All right, so here's your new homework assignment. It's nested statements. So let me just go ahead and download the document so that you guys can take a look. And I don't think we need to talk about this one anymore, because it's something that you know what to do already. First of all, the first time you look at this, you go like, wow, that doesn't look like the usual program that we deal with. Well, it doesn't look like it because I did not indent it intentionally. So the first thing you need to do is to indent this program correctly using the same standard that we use in class. In other words, you will have to locate the beginning and the end of a construct and then indent the content of that particular construct in between. If it is nested, then you have to increase the indentation. So basically, it will look the same as all of the programs that we do in class that are nested with the right indentation. The easiest way to do the indentation, since I'm not going to show you which one you need to indent and which one you do not, I'm just going to take the whole block and indent it, just to show you what button you can use to indent it. I would use, decrease indent and increase indent for this purpose, because that way you can indent the entire block, or you can unindent the entire block. If you use the technique, control click, you can select multiple cells. They don't even have to be contiguous, and indent those cells individually or as a group. Yep.
Is there a hotkey for increasing it?
I do not think so. So hotkey for indent LibreOffice doesn't look that way to me. You can also assign one if you want to, so you can read the articles and find out how to make your own, hotkey. I don't think it's going to be, at least for just one homework assignment, it's not worth it. But it's definitely, if you want to look into it, it's definitely okay too. I'm going to close this. Okay, so that's the first thing you need to do. Second thing you have to do is to start a new sheet. Okay, so you click the little plus sign here at the bottom, right next to sheet 1. So you need to create a new sheet, sheet 2. And then on sheet 2, you will have to label the columns that you need for this particular homework assignment. There are two variables. We have x and z as our variables. It certainly contains loops and conditional statements. And you need the line number. So you kind of know how many columns you need already. So you need to label those columns correctly before you start tracing it. Going back to the homework assignment description here. So this is all it's all written here already. Be sure to use the right columns and state the precondition, since all variables will be initialized in the algorithm. They do not need any specific values to begin with. In other words, you can assume all variables are unknown as a precondition. When you are tracing, be sure to observe all conventions of our traces done in class. So, if in doubt, go ahead and watch the YouTube again, because we have basically gone through the traces many times already in this class. Make sure that your name is the username, and make sure that you are not editing the document in Microsoft Office. We still have about 1 or 2 people either turning in an Excel spreadsheet or have no name in the document. But that's okay, because we are still dealing with low point value homework assignments at this point. But definitely get into the habit of observing the conventions. When you're done, upload the document as your submission. That's it. Are there any questions about this homework? No questions? Yep.
Now going through the steps of that, do you have that exactly in the YouTube last week? To put the indents in.
Yeah, I do it every single time. You mean whenever I write code using LibreOffice, I do that. So we have been doing that all along already. Ever since we do conditional statements, which requires indentation, I've been doing that already.
How do you figure that? You said you work from the outside in, right? That's
right. This algorithm is already done, so you don't have to worry about that part.
Nope.
What you do have to do in this case is to draw a picture. If you look at the source code, even after indentation, if you see that source code and you say, well, I'm not really quite sure what to do after this point or after this point, it is helpful to draw a picture first, okay? Because you might want to see how a conditional statement is inside another conditional statement, which is inside a loop. So I just kind of gave away a part of the answer to your homework assignment. So you might want to mark the time, 14 minutes and 23 seconds into the lecture. Nobody's doing anything. Okay. I take it as a good sign. You already know this stuff, so it's like, I don't need that. All right. So let's take a quick look at nested statements just to make sure that I cover everything. Okay, last time we were dealing with this loop here. So what I'm going to do is I will let me just do the first part of this one. I think I asked you guys to finish the trace last time, right? Or not?
No.
Maybe the other class? Okay, so that was with the other class. This class, let's go ahead and start with this one. So what I'm gonna do is to quote unquote do my homework assignment, but using this pseudocode instead. So it's not exactly the same. This one is actually much more time consuming than your homework assignment, but it will still serve as a good example. So what I'll do is to close this, saving, and start a new document. Start new spreadsheet, and look at the website at the same time. So I'm just going to copy this, and then I'll show you how I do the indentation here. I will trace it up to a certain point, and then you guys can take it and finish this up, because I just want to show you the process of how to get started. After one iteration through the outer loop, I think you guys can take it and do the rest.
SYZ. SYZ.
Say again?
S plus Y plus Z, but I know.
On which line? I think I got it.
7.
Line 7. S plus Y plus Z, X.
Okay,
Yeah.
7.
So, that's an X here. That's an X. Those are X's.
Okay.
All right. So let's go ahead and do the first step first. Okay. The first step is to do the right indentation. So what I'm going to do is to find out, how it is supposed to be indented. And obviously, in this case, some of you have photographic memory and you already remember what it looked like, from the other, slide. But for those of you who do not have photographic memory, you actually get a second chance to learn, because now the answer is not like right in your mind already. So what you want to do is to look at anything that starts with a while or an if, because those are all beginning of compound statements, which can contain other statements. In this case, line 3 is the first one because it has a while statement here. And then what you do is you want to locate the end for this particular while. So when you're doing that, you can scan through the lines. So you can say, okay, we have line 4, it is not while. Line 5 is not, okay. You're looking for end while. That's not end while. That's not end while. But this is important because it's opening another while. It's just like having open parenthesis inside another open parenthesis. Okay, because now you need to remember, oh, we have 2 open parentheses already. So you need to, this one will close this one, and then the last one will close the first one. So you got to make matches like that, okay? Are there any questions about how to match the beginning while with the end while when they are nested? It's just like when you deal with open and close parentheses, the inner ones, would close, open and close, and then the outer one would match the outer one.
You said if or while, right? Is the opening statement.
If it's the same thing, if you see an if, you have to look for the matching and if. Okay. So in this case, we have this while and this while, matching. So you have to indent the content in between. And I just use the indent button here, which normally is shown. I just have a much smaller screen, and that's why they're not shown at this point. Okay. So now you locate the beginning and the end of the outer while, which starts from here and it ends here. So this entire block gets to be indented one more time, and we're all done. So are there any questions about the technique of locating the beginning and the end of a compound statement that can contain sub-statements? No questions? When you have any questions about that, just remember a while is like an open parenthesis, and end while is like a closed parenthesis. If you know how to match parentheses, you already know how to do this. But in your homework assignment, you also have if and end if to deal with, but they work exactly the same way. Are there any questions before we start to trace this? Yes, go ahead.
Okay, so the first while will get like the first indent, and then the second while will get like a second indent, so the whiles won't match up. So
The whiles will not match up unless they are sequential, but these are nested, and that's why they should not match up.
Okay, so anything that's in there will get indented after, like a while. If there was another while, it would be indented again.
If there's another while between line 5 and line 8, yes, that will increase. The content of that while will get,
Okay.
another indentation level.
I have a question.
Yep.
Can you do that indent one more time? Like, you could do it really fast, but I kind of forgot.
Absolutely. Do you want me to use the buttons or just want to replay the sequence?
I just want to replay it.
Okay, so I can just undo and undo. Okay, so this is where it started off. I highlighted these two cells, and I can redo. That's how these two got indented. And then I selected the larger block, which is from here to here, and then I indent one more time. The key, the most important part is really to look for the beginning and the end of the constructs. The actual indentation is done by using this key here. When you are doing your homework, your key is probably already exposed. In this case, because I chose to make the window smaller, and that's why those keys were not exposed. But to you, those tools should be exposed already. So these two are the ones that I would think would be easy to use. Any other questions about this step? Yep.
What about you put the 1 through 10 when you highlight them at the beginning?
You mean this part here?
Yeah.
I just drag this little button here, but this part you don't have to do, is already done in your homework. Yep. All right. Any other questions?
On the homework, you want us to trace it too, or just?
Yes, you have to trace it. You have to trace it in sheet 2.
Oh.
Yep. Not just the indentation. I will definitely not give you an assignment like that. Okay. So create. Yeah, use sheet 2 for tracing. It's kind of implicit here when you are tracing, which means you are going to trace the algorithm.
Also indent sheet 1.
Indent sheet 1 and then use sheet 2 to do the trace. All right, so let's go ahead and trace this one. I'm going to do kind of the same thing that you have to do, which is to create a new sheet in the document first, and then after that you have to label the columns. So in this particular code, I have a while, which means I need to use a comments column so I can document why I make decisions to branch one way but not the other way. I need line number, and in this case I have 3 variables. We have x, y, and sum, which is s, and so we have 3 columns used by variables, and then it's time to get started. The precondition in this case is I don't need to know I don't need to know the initial value of the variables, because they will all get initialized. On line 1, x gets initialized. On line 2, the sum gets initialized, which is 0. And on line 3, I'm going to compare x to 3. And is it true or is it false?
True.
It is true. So once again, I just want to emphasize the convention that we use in this class is you have to repeat the condition itself, and just the condition itself. You don't have to say while x is less than 3 in the comments column. Just say the condition is x is less than 3, and whether it is true or not. Okay, but that part is important. Yep.
If we write out true instead of t, is that
That's fine. You can spell out true, false. I just use t just so that the column doesn't have to be any wider than this. Yep.
If it's false, then you post.
Yes, exactly. If it is post on line 3, when the condition is false on line 3, then you go to false. In this case, it's going to take a while, so we may not get to the end of this one. Then we get to line 4, because the condition is true. In the while loop, when the condition is true, you perform the body of the loop once, and then you go back and then you check again. So in this case, because the condition is true, we go to line 4. Line 4 is going to 0 the variable y, and then on line 5 we have the beginning of the next loop. So now this time we're comparing y to 2, and it is true that y is less than 2 because y has a value of 0 at this point. So then we move on to line 6. Are there any questions up to this point? how we got into the outer loop and how we got into the inner loop at this point, because we are on line 6 right now. Are there any questions about how we got into line 6? I don't think this part is the difficult part. The difficult part is how do we get out of the inner loop and what do we do after we get out of the inner loop. Okay, line 6 doesn't do anything too mysterious. We're just adding 1 to y. Y gets incremented to 1. And then we move on to line 7. The sum is just adding all of the variables, including itself. So sum itself has a value of 0. X has a value of 1. Y now has a value, X has a value of 0, but Y has a value of 1. So if you add 0, 0, and 1, we have a total of 1 at this point. So the sum variable is now updated to a value of 1. So the next question is, where did we go from here? Because we are now at the end of a loop, and we know at the end of a loop we have to go back to the beginning. This is a pre-checking loop, so we have to go back to the beginning of a loop. So that means we have to go back to a while. But we have 2 choices now. We have line 3 and also line 5 starting with the word while. The question is, which one should we go back to?
Line 5.
Line 5, exactly. Because 5 is the end of, is the beginning of this loop. So we have to go back to line 5 and not line 3. Okay, so we have to go back to line 5, reevaluate the condition. It is still true. Y has a value of 1. 1 is less than 2 is true. So we perform this, these 2 statements one more time. On line 6, we increment y from 1 to 2. On line 7, we have to add all 3 variables again. So this time we have 1 plus 2 plus 0, which is 3. And now we are done with the inner loop. So now the question is, where do we go next?
5.
We have to go back to line 5. It is not time to proceed yet, because the only line that can get you out of a loop, in the case of a pre-checking loop, is the first line of the loop, because that's the only line that can make the decision. Are we going to go for another iteration, or are we ready to leave the loop? In this case, y has a value of 2. 2 is less than 2 is false. Okay, so where do we go next?
To line number 9.
To number 9, that is correct, okay? Because line 9 is right after the inner loop. So when we get out of the inner loop, we have to continue execution on line 9. Line 9 is just adding 1 to x. X goes from 0 to 1. And then where do we go? It is at the end while here. So once again, we have to go back to a while line. We go back to line 3 because that's the matching beginning. Is that okay? Yeah. Okay, so we get back to line 3. X has a value of 1. 1 is less than 3 is definitely true. And now we go back to line 4 again. Line 4 is going to re-zero y. So y had a value of 2 already. Now we are resetting it back to 0. And the rest is about the same. I would say, as far as the flow of the logic is concerned, it is about the same as what we have already traced up to this point. The only differences would be the values of the sum, because it would just keep getting, larger and larger. But for the rest, it's not going to be much different. I mean, x is also going to be incremented only. Question?
No.
Right. Yep.
So after that, you just go through the inner loop again?
Yes, we have to go through the inner loop again. So that's why this is going to be a long trace. Yep. Question?
I was going to say we're going to have to go through that.
Yeah, this one is going to be a little bit long, but I think as an exercise, you guys, can try to finish this one first, because as far as the flow of the logic is concerned, it will still be about the same as last time. In other words, at this point, this pattern from here to here basically will repeat itself twice. This is the first time. There will be like 3 copies almost identical of those line numbers. What you will observe to be different will be the value of x, because it keeps incrementing only, and also the value of the sum. But when you look at the value of y, it gets re-zeroed for each iteration of the outer loop. So if you look at the value of y, it goes from 0 to 1 to 2, and then 0, 1, and 2, and then the outer loop would exit after that. So are there any questions about this one? I would strongly suggest the entire class to use this as an example. So even though I'm not tracing it at this point to finish the entire trace, go ahead and do it. If you have any questions about this, you can ask those questions on Thursday, which is still before the due date of your actual homework assignment. So I think this is going to be helpful when it comes to preparing and getting you ready for your homework assignment. Any other questions?
Can we do the while homework? The while?
Oh, the solution of the while statement homework? Yep, absolutely. So let's do that. All right, so the while statement is down here. All right, so here's your while statement homework. Let's go ahead and trace it. So this one, you don't have to set up the trace itself because it's already set up. I just thought that I would just increasingly increase your responsibility. So with the current homework, you have to set up the trace as well. All right, so let's go ahead and take a look at this one. We start on line 1. Line 1 is going to initialize x to a value of 1. On line 2, we evaluate the condition. Is 1 less than 30? Yep, that is true. So we move on to line 3. And what do you think line 3 is going to do?
2.
2. Yep, x becomes 2 because 1 plus 1 is 2. And then where do we go?
Back to 2.
Back to line 2. Very good. Because at the end of an iteration with a pre-checking loop, we have to go back to the beginning, check the condition again, and see whether we have to go for another iteration. X is now 2. 2 is less than 30 is true. We go to line 3. 2 plus 2 is
4.
Go back to line 2. Is 4 less than 30? Yep. 4 plus 4 is 8. 16. Yep, I think you guys are definitely seeing the pattern here. 32. We still have to go back to line 2. Okay, so even though if you just eyeball the whole thing, at this point you will say, on row 13 of the trace, let me just point that out. On row 13 of the trace, even though we can eyeball and say, oh, okay, x is now not less than 30 anymore, we cannot get out of the loop on line 3. We can only get out of this loop on line 2, okay? Because line 2 is the only line that can make that decision, because that's the only line where we perform the comparison and use the result of the comparison to say, oh, okay, x is less than 30 is no longer true, and only at this point we can get out of the loop. Okay, so are there any questions about this trace? Is it a little bit shorter than what you expected? Maybe. All right, so if there are no questions about this, we are done with nested statements. We are now done with the entire topic 2. So let me just go back to topic 2, show you all the topics, and see if you have any questions about topic 2 before we move on to topic 3, which is nasty. Okay, so this is topic 2. Let me just kind of zoom in a little bit, and so we can take a look at the various parts of it. We talk about variables, we talk about sequences, but when we talk about variables, we also talked about assignment statements, and then we have sequences, and then we have conditional statements, and then we have loops, and then the last topic was nested statements. How do we have statements inside the statement inside the statement. So are there any questions about this topic? No questions? Okay. Has anyone started to play with Scratch? Nobody. Okay, now for those of you who want to have hands-on stuff, because that's the way you learn, Scratch is terrific for that purpose. Because it is easy to learn, you don't have to install anything, it is free, Okay, and it can be fun too. I mean, you can see that a lot of people write games and other things, in Scratch. So it's really a kind of a nice platform to get some hands-on experience if you think that would be helpful to your learning of these concepts. So no questions before we move on to topic 3. Okay, so let's go ahead and move on to topic 3. Topic 3 is, it looks easy because if you just look at the description of it, it just says logical expression and how they're used in various kinds of statements, the differences between identify the pre and post conditions of a statement. That really is the kind of difficult part. So what we'll do is to take a look at this one and start with the content already in here. And you know something is not right when the first topic or when the first section starts with a title of what is this crazy math? Okay. So are there any, did anyone read this part before the class? No? Okay. So next time you can kind of start to read ahead of me a little bit, because you kind of know that I'm going, pretty much sequentially through the notes, so you kind of know, where what I'll be talking about next. But this part is okay. It's really just a philosophical kind of question. The question is, what do you need to become a developer, a programmer, or a software engineer? Those three are kind of closely related, and for certain companies, they are used interchangeably. In other words, if you want to become a game developer, okay, or an Android app developer, what do you need? If you ask some people in the Bay Area, you just need to pay $12,000 for an 8-week course, then you can become a mobile app programmer. Well, that's not exactly going to happen to everybody. Okay, some people can do it, but most people cannot. So the question is, what kind of background do you need in order to become a successful developer? Okay, the difference is, there's a very subtle difference here. The question is not whether someone can write programs. The question is whether that person can become a proficient developer and be able or become a software engineer. So there's the question of proficiency, whether someone can be good at that job. Now, is that important? I mean, is that difference important? Okay, example. Do you think I can shoot basketball?
Maybe.
I can throw it, yes. I can launch a basketball at least to the height of the basket. Okay, would I make a good basketball player? I cannot shoot that well. Okay, I can launch it. Doesn't mean I can even hit the basket. Okay, so that really is the difference, right? I mean, so the question is not whether I can launch the basketball in the direction of the basket. The question is, can I, actually get it there? And if I want to play a basketball game, there are other factors involved as well, right? Is that making any sense? So it's the same question here, okay? The question is not whether someone can write code, it's not whether that person can do it, at a professional level, okay? Now I can basically, join my neighborhood kids, and shoot a few, basketball and, be okay with that. They will make fun of me, but that's okay with me. Can I get hired as a professional basketball player? Unlikely, right? Well, it's the same thing here. Some people can write certain apps, can write programs, scripts, and whatnot for for their own purposes. The question is, can they be hired as developers or software engineers? That's the question. Okay, same questions here. All right, so getting back to this slide here, there are two schools of thought. One school was led by Edgar Dijkstra. I think it's a Danish name, and he suggests that a programmer or anyone who writes programs should be a mathematician first, because he was a mathematician. And he basically thought computer science should be a branch of mathematics, just like applied mathematics is a branch of mathematics. So that's kind of how he treats computer science. The other school, which is led by Donald Knuth, And Knuth is still teaching at Stanford University last time I checked. So he's another giant of computer science, but a modern one. He claims that with sufficient advances of tools, everyone can become, can basically program computers. So this is kind of the other end of the spectrum, where he says, okay, everybody can start to write programs because we have easier to use tools now. Okay. Because early tools are really primitive. You have to write programs using really long strings of zeros and ones. But these days, with Visual Studio from Microsoft and other tools that are open source, like Eclipse, it's pretty easy to write programs. I mean, for the most part, the tools are fairly easy to use. Or with Scratch, okay, there's no syntax to learn anymore. Okay, it's just drag and drop. Okay, you drag and drop a block. If it fits, it's okay. If it doesn't fit, it means it doesn't belong there. Okay, and nonetheless, it is still important for programmers to understand enough logic and math. Programming by intuition is possible. It only allows a programmer to get to a certain level. It's just like me, shooting, basketball, on the street with other kids. It's like, well, yeah, I can train myself to do certain things, but I can certainly not become a professional player just by doing that. So here is, so that's the background of, what we are going to talk about in this topic. Are there any questions? No questions? I cannot locate that one comic strip anymore. There was a picture of a computer science student in a computer science class, and the student was just complaining, why do I need to learn all this math stuff? I just want to write some games. Okay, that was the picture. I cannot remember where I located that comic strip, but it was kind of interesting. So what do you think is the relationship between math and computer science? Or why do you think it is even related? This slide has nothing to do with it. So I'm just going to ask you guys to kind of think about it. Why do you think mathematics has anything to do with programming?
Because it's purely logic-based.
It's logic-based, yes. Computer programming certainly is logic-based. And math, how does math relate to logic?
Well, it's just pure logic. There's only one answer. You can't, it's not subjective or relative.
Exactly. And computer programming is the same way too. Okay, there can only be one way to interpret a computer state or computer program statement. It's not subjective. It has to be objective. Well, that's one. There are many other reasons too. I'm pretty sure some of you. Yep. Go ahead.
I'm sorry, this has absolutely nothing to do with what you're talking about. You know how it says exam 1 practice?
Right.
When is our exam?
That is a good question. Because I usually do it after I talk about pre and post conditions and include this as a part of exam 1. So it depends on when I'm done with this topic. So there's no set date to it. It's just after we finish this topic. Yep.
But you will give us a heads up.
Yes, definitely, because before any exam in this class, I give you a practice exam exactly 1 week before the actual exam. So you will get at least 1 week's notice, because I will go over some questions in class to help you get ready for the exam. All exams in this class are open book and open notes. In other words, you can bring in anything that is either printed or handwritten prior to the test to help you in the test. But not computers, okay? No mobile devices, no computers. It has to be all paper-based. But it's open. I mean, if you can find 20 books that you think might be helpful, get your hand truck ready. The most successful students tend to bring in handwritten notes. They basically study, they review the material, and then they jot down some notes and say, okay, I think this is important, or this is something that I might forget during the test. So they only bring in 1 or 2 sheets of paper with the rest printed and in a binder ready, just in case, okay? But the most frequently accessed ones will be on 1 or 2 sheets of paper. But in the process of preparing that 1 or 2 sheets of paper, these students typically would review enough of the material that they actually do not need that 1 or 2 sheets of paper anymore. In other words, those two sheets of paper become the feather held by a Dumbo. You guys remember that anime from Disney?
Yep.
Okay, so it's the
Flying
same thing. Flying elephant, exactly. So I'm going to pass the row sheet at this point. See, today I remember. Most of the time I forget. Of course, I still have to find the right one first. It's this one. Pass it here. Okay, so we'll go ahead and get started with pre and post conditions. The context of this whole discussion has to do with something that we have gone over quite a few times already. Looking for the marker of the other color. But I think you guys remember, last time when we talked about it. Remember how I used a big solid color to represent all the possible input to a program, and I used dots to represent the ones that are faulty. Okay, those are the test cases where a particular algorithm will fail. It won't do what it's supposed to. Do you guys do kind of vaguely remember that picture? Okay. So the question now is, if you use an approach of throwing darts at it, you can throw a lot of darts and not have one single one landing on a bad test case. In other words, you would not spot the problem. But on the other hand, just having none of your darts landing on a bad spot, it doesn't mean that your program is working either. It simply means that you have not found a flaw yet. So not having found a flaw is no indication that the algorithm is correct. Does everybody understand that part? Because the easiest way of not finding any flaw in a program is not to test it. Right? If you're not testing a program, you cannot find any flaws in it. But it doesn't mean your program is going to be perfect. Yep.
But it does mean that the algorithm is correct for the cases that you have used.
Correct. If you throw test cases at an algorithm, and those test cases work out, then you have confirmation that the algorithm works for at least those test cases. The question is, will it also work for all the other cases after the program is deployed? After you distribute your app in the app market with all the other users using your app, will it still perform correctly with all of those other people using it? That really is the question. Okay? So what we're going to do here is to get the concept of a precondition. A precondition, I'm just going to highlight the portion here, is simply stating what do we know about the variables in an algorithm before the execution of that statement or that line in the program. That's all we are saying. Okay? What do we know about the variables? How do they relate to each other? Do they have specific values? What can we say about the variables right before the execution of a statement? And as a result, or as a second part to this discussion, a post condition is the other one, which is basically saying right after we execute a line in an algorithm, what can we say about the variables? Okay, what do we know about the variables? Now, the most important part is the post condition of one statement will feed into the precondition of the following statement, because when we have a sequence of statements, the post condition of the first one becomes the precondition of the second one, and so on. So if you chain the pre and post conditions, then you can eventually get to the pre and post condition of the entire program, of the entire algorithm. Because if you can tell me what is the post condition of the entire algorithm, then you have a way to basically state, is that what we want this algorithm to do? Are we making any sense? Okay. So now let's go ahead and consider an algorithm. The precondition of the entire algorithm is basically saying the input to the algorithm, are there any constraints? Now, sometimes there are no constraints to the input of an entire algorithm. Then you have very little to say about the variables. You can say, anything goes, there are no restrictions. But other times you might have restrictions already to certain algorithms. So you can say, we can make these assumptions as starting points. The post condition of an entire algorithm describes, the output of the program. Okay, mathematically, how can I describe how the variables in the program relate to each other, or specific values in the variables? Now, being able to derive the post condition of an entire algorithm based on its own precondition means we can prove whether an algorithm is doing what it is supposed to. Okay? So we can go through a few examples, so that we can kind of understand what this means. Now, if you can do this using mathematics to derive the post condition of an entire algorithm, that also means we don't need to use test cases anymore, because it's already proven once and for all that it will work for all values of x, y, and z, or whatever. I mean, it depends on the variables. But there's no need to test individual test cases anymore, because we have just proven it once and for all that it will work for all cases. So are there any questions about the rationale of talking about pre and post conditions?
You also run through that sequence in, for example, like Microsoft Office when they send it out. Do they also receive information how's function? Like how is the user using it? I mean, how is it behaving? Is it behaving properly, or?
You mean how does Microsoft test their program, or how do they make sure that their software works correctly?
Yep.
I have no idea. That's actually probably trade secret to individual software companies, is how they test their software.
But they run through that sequence through the pre-post?
No, probably not.
No?
But as we go through this topic, we'll see that this is the holy grail of computer and software engineering, which means it's ideally speaking we want to be able to do this, but practically speaking we cannot do it to complicated algorithms just because it would take too much time. Not because it's impossible, it's just impractical to do it. But the skill set that you develop when you go through this topic will be useful when you need to debug your program. So we'll go over some of that stuff too. Okay, so what we'll do is we'll start with some examples. Okay, so we'll start with, and in this case I don't need a spreadsheet because we are not tracing anymore. Okay, in other words, for the entire topic, topic 3, we're not going to trace anything anymore, because remember, we want to get rid of test cases altogether. Okay, we want to use mathematics to describe the behavior of an algorithm, not using test cases. So we're not going to say, oh, if x equals to 5 and y equals to 10, the output is going to be blah, blah, blah. Nope, we don't want to say that anymore. We want to say, I don't care what x is, I don't care what y is, but the final result is this, and this involving x, this much involving y, and so on. So let's go ahead and take a look at an example. And I'm going to turn off line numbers, because I'm going to use my own line numbers here. So let's say this is line 237 of some really long and complicated algorithm. And all that line is really saying is x. I'm kind of debating with myself, what I should be using. So let's start with something that is that we have seen already. X gets x plus x. Okay. And the precondition is given to you. Don't ask me why the precondition is the precondition. It has to do with the 236 lines before this line. Okay. But at this point, I know that if I ever get to line 237 and it's about to execute it, this condition is guaranteed. Okay. So pre-237, this is the notation of the precondition of line 237 in this class. So I'm going to say that for the reason of the 236 lines prior to this line here, I know several things. I know that z has a value that is less than 200. I know that x is greater than or equal to y. And I also know that x is, let's say, less than 245. Doesn't matter. Just pick a number here. Okay, that's my precondition, which means, do I know the exact value of x, y, or z? No. The precondition says I do not know the exact values of each variable, which means I'm not tracing. This has nothing to do with tracing. In order to trace, you need to know the exact values of the variables to proceed to the next statement. This is not, I mean, it tells you something about the variables, but not quite exactly the values, okay? So the question is, just using your reasoning ability, can you say something about the condition of the variables right after line 237 executes? That's the question, okay? Knowing what is coming in, can you tell me what is, the condition going out of this particular statement? Well, let's pick the preconditions one by one. Do you think x is still less than 200 after line 237, but it was already guaranteed before, right before?
Z.
Z.
Yeah.
Yeah. Why? Why can I continue to state that Z is less than 200?
Nothing.
Change.
Yeah, exactly. Because line 237 has nothing to do with Z. So whatever it was before, whatever I can say about Z before, has still to be true because there's nothing changing Z on line 237. Is that okay? All right. Let's take a look at the other two because they look kind of nastier. Because one says x used to be x was guaranteed to be greater than or equal to y before line 237. Can I still guarantee that?
Yeah, probably.
Yes.
But x can be negative. X can be negative.
What about
What if x is
2x
negative?
or x divided by
Then it becomes, it could be less than y at that point.
That cannot be guaranteed anymore. Yep.
Well, actually, can't it be? Because he guaranteed before that x is greater than y, so unless y is negative, then you could possibly have x be negative, I suppose.
Okay, let me give you an example now. Okay, so the question is, can I still guarantee this? Okay, so I'm going to put a question mark here. So what I'm going to do is to say, well, I can throw one particular case at a precondition here, and basically say, okay, let's say x started off with a value of -2, and y started off with a value of -3. Okay. Now x started with -2, y started with -3 as a precondition meets the requirement that x has to be greater than or equal to y. Does that make any sense? But when I double the value of x, it means x now becomes -4. And -4 is greater than or equal to y is no longer true. Does that make any sense? So it seems like we have lost that piece of information altogether, but that's actually not true either. Because when we look at this statement here, is it something that is undoable? In other words, if I know the result after line 237, is there a way to reverse back to the value of x before
Yes.
line 237? Yes. Now
Minus
that
x.
is, sorry?
X minus x?
Divide by 2?
Divide by 2. Divide by 2. So if we know the value of x after line 237, we can divide it by 2 and get back to its own value before that particular line. Is that making any sense?
Why would you bother?
Why would I bother?
Yeah.
Because I know how that value related to y prior to this state. So if I can reverse, I can now say, hey, you know what? I know that x has doubled. So that means if I divide it by 2, that number still has to be greater than or equal to y. Is that making any sense?
Yeah.
Now this part is very important. Later on we'll kind of formalize how we perform this type of reasoning. But this is really important because it tells us, hey, we don't have to throw things away unnecessarily. Because every time we throw something away, we're losing track of some information. We want to maintain as much information as possible when it comes to deriving the post condition from a precondition. So now we can actually keep that piece of information here and just say that, well, we don't know whether x is still greater than or equal to y, but we know 1/2 of x still has to be greater than or equal to y. Yes?
If you were to put x minus x is greater than or equal to y, would it not
That would not be the same because x minus x is always 0. So it's always it's x divided by 2. Because x divided by 2 reverses the operation of x plus x. But x minus x does not reverse that. We'll talk about the inverse function concept as well.
I guess I'm trying to figure out what x are we talking about. Do you see what I'm saying?
That's exactly the point. We don't know exactly what value x has at that point. The only thing we know before we get to execute line 237 is really this part here. That's the only part that is guaranteed. But we don't know the exact value.
But no, what I mean by what x is, I'm meaning is it the x on the right side or is it the x after you add both and now you're switching it to that x? Do you see what I'm saying?
I think it would be
Okay.
easier to write 2x divided by 2 is greater than or equal to y.
No, I mean, I
Okay.
get x divided by 2, but I just don't know what x we're talking about.
Okay, the precondition refers to the value of x before the entire statement.
Okay.
The x in the post condition refers to the value of x after that statement.
Okay.
So it has nothing to do with the x on the left or the x on the right because they really are the same variable. Okay? So the precondition refers to the value of x before we execute line 237, and post condition refers to the value of x after line 237 executes. Is that okay?
Yeah.
But what happens exactly when we execute line 237 is not documented by the pre or the post condition. Yep.
I was kind of confused myself, so I was just going to suggest that you put the line 237 between the pre and post. So, like,
Oh, okay, sure, we can do that. So the precondition is that we execute the statement, and then the post condition becomes that. Good suggestion, thank you. Okay, we have one more piece to go. Okay, so before the statement, we can say that okay, for whatever reason, I can guarantee that x is less than 245 before line 237. Okay, don't ask me why. Okay, because it has to do with the 236 lines prior to this line here. So the question is, do I have to throw this piece of information away altogether, or can I just kind of modify a little bit and keep some kind of relationship of x with 245? Well, we can do the same trick, right? Yes, we just say that, well, now that we know x has doubled its value, if we divide it by 2, having the double, then we get back to the original value of x before line 237 executes, and we were told that value is less than 245, so we can kind of keep that information. We just tweak it a little bit. Are we still doing okay so far with this example? Yep.
So, if I'm understanding it right, the idea of pre and post is to try to maintain as many relationships as you start with between the whole
Yep.
thing. Okay.
Yep. Sometimes you're adding some too, depending on what kind of assignment statement you're dealing with.
Yeah, so if there would be like x plus x minus 2, then we would have x divided by 3 minus a number, like.
You're getting into the inverse function thing. Yes. Then you have to do whatever it takes to reverse the operation. Now, some operations are not reversible, so it doesn't work that way. Okay. So I'm going to give you another example where it doesn't work the same way. Okay. So the other one would be the precondition of line, let's say 16 in this case, early on in some algorithm, may not even be the same one. So we're going to say I is greater than or equal to 0, and j is less than k, and that's it. Okay. That's my precondition of line 16. And line 16 is going to say something like this, okay? X gets initialized to a value of, say, 20. Okay? So what can we say right after line 16 executes? Because yep, exactly. So I is still greater than or equal to 0, and j is still less than k, right? Because line 16 does not change I, j, or k. What else do I know at this point? Don't I know one more thing now? X is 20. That's it. So occasionally you can add new information, and other times you have to take out information, from the precondition. But you can see how, this can change to the next statement. Knowing the post condition is like this for line 16, it serves as the precondition of line 17. So now we can kind of chain and connect all of these statements and start with the precondition of the entire algorithm and come up with the post condition of an entire algorithm, which is the objective of this entire approach. Are we still doing okay so far? Okay. So let's go ahead and take a look at something a little bit more complex. Now, I'm kind of doing this right now on a very kind of ad hoc way. So later on, I'll have a general method so that you guys have a much more mechanical way to look at statements and say, okay, if I see something like this, how do I derive the post condition? So that part will come later. I just want to give you, certain exposures at this point. Let's take a look at something that we have seen many, many times. I hope you guys still remember this.
Yeah.
It's the algorithm to find the maximum of two variables and store that into Z. Okay, so we want to derive the post condition of this entire thing. But I don't want to place any restrictions on line 1. In other words, I don't want to say, well, x is less than this value and y is greater than that value, or anything along that line. In other words, I want to say, I want to see how x, y, and z relate after this algorithm executes, regardless of the beginning value of x, y, or z. Am I doing okay so far? Because when I try to solve that problem, finding the maximum of x and y and store it into z, did I ever say anything about, well, this algorithm will only work when x is even and y is odd? Did I place any type of restrictions on x and y when we talked about this algorithm? We did not. Okay, so as a result, I don't want to place any restrictions here either, because I want to see what the algorithm is going to do for all possible values of x and y. Okay, so how do we say something like that? How can we say anything goes? In other words, what is the one thing that is true regardless of the values of x, y, and z?
X is greater than y.
No.
X and Y can be any number.
X and y can be any number, but I need a Boolean expression. I need an expression.
X is different from 1.
X is different from 1? No. I want to see how this algorithm will work out when x does equal to y, because there's a definite answer as well for that. X.
Z is greater than or equal to x or y.
No, this is the precondition, not the post. So the precondition is true. What? The precondition is true? Okay, so remember what a precondition is. The precondition is a statement or condition that has to be true, that is guaranteed to be true prior to the execution of a particular line. That is the meaning of a precondition. Yep.
But what if, do we have to specify that x has to be a number, not?
Well, that's kind of given, that we're working with numbers here. Okay, so that's a good question, but we are kind of, at this point, all our variables are numbers. Just plain numbers, real numbers. Okay. But that is the simplest statement that is always true, right? True is always true. It's just like 0 is always 0. Give me the simplest expression that is always 0. 0. Yeah, exactly. So this is kind of special because it means that we're not saying anything. If the precondition of a particular line is just true, it is the simplest statement or simplest expression that guarantees to be true regardless of the values of any variables. Is that making any sense? So if a precondition can be true, can it also be false? The answer is yes, it can be false as well. If the precondition of a line is false, it means we will not get to that line. Okay? We'll see that also, okay? Later on, we'll see multi-branch conditional statements where we can have certain statements having a precondition of false, and that means, okay, here's a dead branch, don't bother to analyze it because we won't get there. Okay, so let's go ahead and proceed with this one. Okay, if the precondition of line 1 is true, what would be the precondition of line 2? In other words, if I'm about to execute line 2, what can be guaranteed? Now, this really helps if you draw a picture of the algorithm. Okay, so I'm going to draw a real quick picture here so that it will help you analyze what to say here. Okay, so I'm just going to draw the picture of a conditional statement. A picture actually helps in pre and post conditions too, so definitely should consider that. Okay. All right, that's the general picture. I'm not even going to bother to finish up the blocks here. Pre1 is here. Okay. Before we even make a decision, what can be guaranteed, or what is guaranteed to be true? Okay, I can guarantee that true is true. Good. Are we doing okay so far with pre1? Okay. So pre2 is basically, this is statement 2 and this is statement 4, right? In terms of the line number. So pre2 is really asking, if I'm here, I'm just about to execute line 2, what can be guaranteed? Or is there anything that can be guaranteed?
Z.
X is greater than y, because otherwise we wouldn't take this branch, right? So that makes sense. Okay. But you know what? I'm going to say something that is a little bit more than that, which is pre1 has to be true also. In other words, in this case, it's just the way that it is arranged that pre1 is true. The reason why I would use pre1 first is because what if pre1 is not a simple true? Well, it would still be true by the time we get here, because just comparing x to y does not change the value of anything. So that means whatever was true before the comparison still has to be true, but on top of that, we also know that the comparison is also true, which means x is greater than y is true here.
Don't we also know that z equals x at this point?
After that, as a post condition of line 2, we will know that. But are we still doing okay so far with the derivation here, that pre2 is true and x is greater than y? Can we simplify this? Can we simplify x true is x is greater than y to just x is greater than y?
Sure.
Okay, but why? How can we make sure that this step works out for all cases?
Because we haven't the numbers yet, or we don't know the values. Nothing is changing.
Nothing is changing. But how do we know that true and anything is just anything? That really is the question. In other words, how do you know in arithmetics 1 times x is just x? Go ahead.
So I'm guessing for true and the x greater than 1 is that since something has been true, we got to the result of that x greater than 1 is true. So
You mean x is greater than y?
yeah, greater than 1. So because we executed that one, so then that means the previous statement was true, that we could execute that.
Okay, let me turn on the line number so you can tell me which line you're referring to.
So I'm not sure about that, but
That's okay.
what I'm thinking is that we got to 28 because we know 27 was true.
Right. If you know this is true, how can you guarantee that that is also true? That really is the question.
You can't.
Well, there's an easy way to do it. Okay. So what I'm going to do is to show you how easy it is to prove axioms in Boolean algebra. Okay. In arithmetic algebra, you have something like this, right? 1 times x is just x, right? Does everybody agree that 1 times x is just x? Yep. Okay. But that's usually given to you, okay? It's not proven to you. So what we'll do is we'll do a really quick way to prove, true and whatever is just whatever, okay? So how can we do that? Well, we'll go ahead and take a look at the truth table. Okay, we have A and B being two independent Boolean variables. And then we look at A and B as a combined, as an expression. A can be true, A can be false, because it is a Boolean variable. When A is true, B, being independent to A, can also be true or false. When A is false, B can be true or false. Does everybody agree that lines 32 to line 35 kind of documents all possible combinations between A and B? When I tell you ahead of time that A must be Boolean, it can be true or false, and B is also Boolean, it can be true or false. That these four rows will represent all possible combinations between these two variables. Okay? This is not something you can do with numbers, because we have an infinite number of integers, right? So we can't really quite do the same thing with integers. But with Booleans, hey, it's easy. We only have two possible values. It is possible to enumerate all possible cases. Okay? And by the definition of and, we already know this part. True and true is true. True and false is false. False and true is false. False and false is also false. Yep, we talked about that a long time ago. Everybody knows this part already. But what does it have anything to do with true and whatever? Is just whatever. I don't see the connection. Well, let's take a look at the first two rows here. Okay? If you just focus on these two rows and forget about line 34 and line 35, if you just look at these two rows, don't they just document everything that we have to deal with when we're dealing with true and whatever?
Yeah.
Okay? What does it tell you about true and whatever?
It doesn't have to be true.
It's just whatever, right? Because true and true is true. Hey, this guy is the same as this guy here. True and false is false. This guy is the same thing as this guy here. So we have just identified the identity property of conjunction. Identity property means, that's the identity operator, whatever, gets whatever back. So for multiplication, it's 1. That's the identity. For addition, it is a 0. 0 plus x is x. Are we still doing okay so far with that little simplification? Now, knowing this allows us to go from line 27 to line 28, because we can just get rid of the true and here and just say that, that's silly, it's not adding any more information. Are we still doing okay so far? So I'm going to finish up post 2, and then when we come back on Thursday, we'll start with pre 4 and then post 4 and then finish the entire statement. What do you think is post 2, knowing that pre 2 is x is greater than y?
X is greater than y and x equals z.
And z and x are the same. Very good. Now there's one common mistake that people make here. Some people use the assignment operator here. That would not be correct, okay? Because we are not performing an operation here. We are trying to state the relationship between the variables. So do not use an assignment operation inside the condition. Okay? Now this is great, okay? It's great because what it's saying is when we are about to get out of this block of code here, when we're here, we know two things. X is greater than y and z equals to x. So we can now apply about the same type of technique to the other branch. Okay? So we end up with a precondition here and a postcondition here. The big question is how do we combine it into the final result here, which is post 5? What is the post condition of the entire statement? Can we look at this and say, yep, this algorithm will work for all possible values of x and y, and will always find the maximum? That really is the question. So we'll answer that question on Thursday.
In Scratch was the MIT program you're talking about?
Yep.
Okay.
Scratch.mit.edu.